Okay, good morning everyone, welcome back. So last time we talked about organization of the electricity supply industry, and today we're gonna keep talking about this stuff, and we'll finish chapter 1 today, and if time is allowed, we will have a quiz. I think we're already prepared for that. So let's see what we discussed last time. Conditional electric utility model. So this is a multiple model: generation, transmission, distribution, and retail. And we are here. We are customers. And so why vertical integration? We said natural monopoly. Monopoly is efficient at the early stage of this kind of social capital. So highway, electricity, water system, gas system, etc. So yeah, these are the advantages of monopolies. And that was called natural monopoly. And there are two types of monopolies: private or public. So private means investor-owned utility, and public means the municipal or utility district or national. So yeah, these were the examples of private-owned utility or investor-owned utility, and this is the example of public monopoly. Another example of public monopoly. So you see, there are thousands of utilities in the United States. Some of them are investor-owned companies, municipal systems, public power district, state, county systems, rural electric corps, and the U.S. governments. And because we have a single company, we need to have some regulation. And the private monopoly could abuse its position. That is said, they exercise market power. Actually, the market power is typically used in duopoly. So monopoly means there are a single entity, duopoly means there are two entities, and the opposite of those things is the fully competitive market. Okay, so monopoly, duopoly, blah blah blah. And yeah, so I think we talked about regulatory compact last time. And in Korea, this is called 규제 협정. So what it says is, okay, the government needs to regulate, but it should be based on some contract or compact. So I uploaded article about the regulatory compact in Korea. That was the newspaper article was published last year, and that is about the direction of the current government about the liberalization of electricity market and the electricity price. So yeah, IOU, so regulatory compact is an agreement between investor-owned utility and a government. Government regulates IOU, but they should be based on some agreement or contracts. And so IOU accepts the price or the rates that is suggested by the government. And the example is Washington Utilities and Transportation Commission. WUTC will come again today. And yeah, we talked about rate of return regulation. So rate of return is just, this is an easy concept. Rate of return means when you invest some money, how much you can get. Okay? So in Korean, this can be called 수익률. Okay? When you invest some amount of money, how much you can expect to get. So actually, the equation I explained here last time was about internal rate of return. That is called IRR. So this is nothing to that one. So I'm sorry to confuse you. So here, rate of return is just how much you can get when you invest some money. Okay. The concept of rate of return is typically used in investment, any kind of investment. You can invest on the stock market, for example, or you can buy some Bitcoin, something like that. So the rate of return regulation means that the regulatory body can restrict the amount of rate of return. So they allow this rate of return to recover the operating cost or investment cost, something like that. Okay? And in this case, a monopoly utility is a low risk investment because there is no competition, and they will not go bankrupt. Because if that happens, our society will be experiencing many difficulties. Okay, so the government and the people in the country do not want to do that. But anyway, the rate of return can be low compared to other investment because this is regulated. By the way, 1, 2, 3, 4, 5, 6, 7, 8. I think one student is missing. So actually, 2 students are missing. One student is in Europe, another student is in Korea. And why he is not here? I need to ask him at the end of this class. Anyway, the problems with private monopolies is that, as you may imagine, the monopolies are inefficient because there is no competition. And because there is no competition, they do not need to be efficient to survive. This is the typical drawback of monopolies. And yeah, no incentive to be efficient because utility earns more if it invests more. What it says is, okay, utility invests to build some power plant or transmission line or distribution network to expand the network capacity. Then the regulatory body says, okay, you spend this amount of money, then you need to recover the cost, so I can increase the price of the electricity, something like that. Okay. So, yeah, hypothetically, when they invest, the utility can get more. So, in English, they can be said, there is no penalty for building white elephants. What is the meaning of white elephants? Is there anyone who knows the meaning of white elephants? What's your name? Oh, Kyung-young, yeah.
Can I speak in Korean?
Sure, why not? They can understand Korean.
자기가 감당할 수 없을 정도로의 그런 선물 같은 걸 원래는 시작으로 옛날에 태국의 왕이 자기 신하 마음에 안 드는 신하에게 흰색 코끼리를 줬다고 하는데 선물로 신하는 그 코끼리 왕이 준 선물이니까 거절할 수도 없는데 코끼리를 키우려면 엄청나게 많은 돈이 비용이 든다고 합니다. 그래서 결국에 그 신하는 망하게 됩니다. 그래서 거절할 수 없는 그런 선물을 자기 수지에 얻지 않는 선물을 많이 타게 됐죠.
Yes, great. How did you get to know that?
예전에 책에서
Wow. Yeah, his explanation was excellent. And so in Korean, that can be said, 물상지. Okay. So, the utility may build white elephants to earn more money. Okay, and the result, the consequence is that that kind of high cost are passed on to customers as high prices of electricity because of rate of return that is determined by the regulatory body. Okay, and this can happen because a bankrupt utility is in nobody's interest. So we have a problem with private monopolies. And rates can be higher than they should be. That means this is not efficient. Then could the regulators regulators. Could the regulators do better? Actually, regulation is difficult, and the first reason is that there is little basis for comparison. That means each regulator oversees a small number of utilities. This oversees means supervise. This is different from overlook, the English word, okay? Each regulator oversees just a small number of utilities. So, yeah, and each utility has a territory with different characteristics. So, yeah, there is a regulator, and there are several utilities, but each utility has its own territory with different characteristics. And they may say, hey, we have this kind of difficulties, we have this kind of situation. So, yeah, and that's why we are saying regulator has little basis for comparison. And also, it is difficult to evaluate the utility's decision. The reason is because there are not many workers, employees in the regulators. So regulator does not have as much as staff as the utility. And so we can say there is information imbalance. The regulator cannot know the utility in and out, inside out. What can I say? 속속들이 알 수 없다. Because there are not many steps as the utility have. So, okay, then let's think about the problems with public monopolies. A good government will run its utilities in an efficient and fair, far-sighted manner. Yeah, that's an ideal case, but this is not always the case. Conflict can arise between the objectives of the government and the objectives of the utility. Well, this is an interesting case, and let's see. Yeah, so in the next slide, we will see this kind of, what kind of conflicts we can expect. Okay, so government monopolies can be inefficient too. And let's see the examples. What are the things that governments can do? The first one is keep rates low to please voters. This kind of thing is called, these kind of things are called populism. Okay, so when there is an election, we are experiencing this kind of populism. So utility does not have enough, yeah, so utility does not have enough money for investment because the electricity price is too low to satisfy the voters because of populism. And, or the opposite can happen, keep rates high and use the surplus money for other programs. What it says is, yeah, because the government can increase the electricity price, they can get more money, and this is another kind of tax. Okay? So, this is kind of taxation, but inefficient taxation. Because when we impose a tax, what can I say? I pay, the tax rate is, so my tax rate is higher than you expect. But for this kind of case, everybody's electricity price will increase. Okay, so this can be considered as a tax, but inefficient taxation, and not good for social welfare. And inefficiently high electricity price discourages the consumption of electricity. Even if this is too hot, people cannot run their air conditioners, for example. And force the utility to make unnecessary investment to create jobs. This is another interesting case. Well, actually, you know, when the economy is under depression, like 1930s in the United States, you may know what the government did to stimulate the economy. Who did what? In 1930s, there was a great big depression in the United States, and so the government needed to stimulate the economy. So my question was, in 1930s, what the United States did to stimulate New Deal plan and build a big dam, for example, football dams, something like that. Okay, so that kind of thing can be good to stimulate the economy, but no, that cannot be good all the time. So this is the downside of that. So force the utility, hey, I'm the government, this is the utility, and there are many unemployed workers. Then the government order the utility. You need to hire these unemployed workers and build something. Okay, that may be inefficient if there is actually unnecessary investment to create jobs. So we need to think about a new electricity supply model. And the first one is the privatization of public utility. What is the meaning of privatization in Korean? Yeah, this is called 민영화. And still, the highway, the 한국도로공사, that is about highway and the roads maintenance and building the roads. That is public. But the KT, Korea Telecom, was a public company, but it was privatized around 2000. So at the time, I went to KT. Okay. Anyway, so privatization of public utility is one way of new electricity supply model. But this is not the case in the United States, but primarily in Europe and South America. Okay, and another model is unbundling. Unbundling means the opposite of bundling. Okay, so bundling means we can group the things together, but unbundling means we separate the things depending on different functionalities of the utility. Actually, this keyword unbundling was also used in the privatization of the telecom company in Korea, and in the United States and in Europe. So, in the case of telecommunication company, this unbundling meant the unbundling of local loop. Here the local loop means the access network from the central office, 전화국, central office of the telecom company to the customers. Okay, and the customer is connected to the central office by a copper line, the twisted pair. So around 25 years ago or 30 years ago, at the time people didn't have an access to the internet, right? But around 2000, the Hanaro Telecom appeared. And they said we can provide high-speed internet access to every residential customers using the twisted pair. And that service was called what? You will know that. At the time you were born, right? 1989. 1989. You were born. you were 3 years old, 4 years or something like that. Anyway, the Korean famous singer, he was known for his denial of military service. Lee Sung-jun, he was the model of Hanwha Telecom ADSL. 나는 ADSL. Commercially, something like this. So anyway, so that is kind of unbundling. So even though the Hankook-Dongsin, the Korea Telecom owns this access network couple line, Hanwha Telecom requested to unbundle this access network so that we can provide another types of service, high-speed internet service. Okay? So this access network is owned by Korea Telecom. But another entity can provide some additional new services using that entity, using that access network. That is kind of unbundling. And similar concept can be used in power systems. Okay? So distribution network is owned by some entity, but another service provider can provide new types of electricity service. Okay? That is called unbundling. And also we can introduce competition. Competition means we want to treat this electrical energy, a megawatt hour, as a commodity. This commodity is a terminology in economics. Okay, so in Korean, this is called Ch1. So in economics, this commodity can be exchanged, right? And there is some price about the commodity. And we want to determine some proper price for the commodity. And that is determined based on, as you know, supply and demand by invisible hands. That was the idea of the economist who coined the idea of invisible hands. Yeah, Adam Smith. Okay, what is the title? What is the title of the book he wrote? In Korean. Buron, yes. Interestingly, in that book on the wealth of nation, there is no equation at all. But that describes the fundamental things of microeconomics. Anyway, where am I? Yeah, so treat the electrical energy as a commodity and create markets. Yeah, create markets for trading this commodity. And energy transmission and distribution remain services provided by monopoly companies. So this is interesting statements. This transmission and distribution network are managed by a monopoly company, but we can introduce a competitive market. Okay. Any questions so far? You see what I'm saying? Okay. And what are the expected benefits of privatization? Utility can focus on its mission, and if markets function properly, utility gets the revenues it needs, and the price of electricity reflects its true cost. And based on that, we can expect optimal allocation of economic resources. Yeah. Actually, in economics, we usually do not use this terminology optimal. The economists prefer the terminology efficient. So, anyway, optimal allocation of economic resources. That's the role of electricity market. And we want to have the price reflect the true cost. The true cost means the generation cost and the maintenance cost of the transmission and distribution networks. Okay. So this is the ideal case. Okay. That means this is the ideal case, and in reality, each country has their own difficulties and situation. And yeah, the expected benefit of privatization. And this is access to private sector capital. That means, okay, in the case of monopoly, we have private monopoly and public monopoly. In the private monopoly case, actually the government doesn't need to worry about who invests. Anyway, there is a private investor who invests and manage this IOU, investors-owned utility. But in the case of a public monopoly, governments need to invest and they need to spend money. But when this privatization is introduced, we can expect other investors to invest in this business, right? So this is important in developing countries when government is short of money for investment. Okay, so in the developing countries, this can stimulate the economy because the government doesn't have much money to invest, but then other big guys with a lot of money want to invest and build a network and provide services and get money and share the revenue. Okay, so actually Korea is also interested in investing other developing countries to get profit. But in the case of this privatization, that means previously the asset is owned by the government, and this is privatized. That means this asset is sold to some other entities, and then the government can expect revenue from the sale of privatized assets. But this kind of revenue is just for short term only. Okay. And expected benefits of unbundling continues. The separation between the parts where competition is possible and those where a monopoly is needed. So as I told you, we have many parts: generation, transmission, distribution, and retail. And in the case of privatization, we don't need to privatize all parts. Some parts can be privatized, but some other parts can still manage it by a monopoly company. Okay? So, yeah. And the generator side, that is the easiest part to privatize. So competition between generators was introduced in Korea in 2001 or 2. Actually from 2001 to 2002. But still, in Korea, the transmission and distribution network is under monopoly by KEPCO. Okay, so in Korea, we have this kind of hybrid structure. And yeah, because of the benefits of unbundling, because of this unbundling, we can expect more transparency in the system. And this is essential to create a fair market. What does this mean? As I told you, the unbundling case in telecommunication company, if we didn't introduce unbundling, Korea Telecom was the only operator or the service provider that can provide internet access service. Because of this unbundling, we can have different internet service providers, and you can enjoy the high-speed internet access. Very cheap. Yeah. And I was the one who developed that kind of system 20 years ago when I worked at KT. From ADSL to VDSL, very high-speed digital subscriber line to fiber to the home. Yeah. Anyway, nobody cares those things these days. internet is kind of utility. Right? Anyway, so that is essential to create a fair market. That means an independent system operator, this is a very important keyword and this will come up again. An independent system operator will not favor one generator over another. So that means, you know what it means. This is fair. So generators need to compete to get into the market at a cheaper price. So, we want to introduce competition, and generators need to become more efficient, because if they are not efficient, what does this mean? Actually, later we will introduce the generation cost function. But let me write it here. Let's say C is the cost to generate. X is the power, measured in kilowatt or megawatt, and this is multiplied by some constant plus another coefficient which is proportional to the amount of power, and another coefficient which is proportional to the square of the amount of power. So here X is measured in kilowatt or megawatt. Okay, so the generation cost of a power plant, the generators, can be modeled based on this quadratic function. This quadratic function is a convex function. So this is a very typical optimization problem with some constraint. What is this? This fixed cost. What is this? Well, you can expect the fuel cost, right? The oil or natural gas. But actually, we have this quadratic term. What do you think the most dominant term is? C0, C1, or C2? Yeah, C1, this is the most dominant term. And the C2 is very small, 0.00, blah, blah, blah. Anyway, this is a convex function. But this C0 should not be neglected, because this fixed cost is also important, and is about the decision of turn on or turn off the generators. When the generator is turned on, even if it generates zero power, it still needs to consume some money. Okay? That's the meaning of fixed cost. When the generator is turned on, it generates zero power, but still it incurs some cost. So to save money, we need to turn off the generator, but turn on and off, this is a binary decision, right? And turn on and off also incurs some cost and time. We cannot expect the turn on the generator and immediately generate power. It needs to take some time. Okay? That time is called ramping time. So generators are very similar to humans. Or so when we do some exercise, we first need to warm up, right? And then we can swim at our full speed, for example. Similarly, this generator also needs to warm up itself. Okay, so it requires some ramping time. Anyway, so in terms of operating generators, we need to consider two things: whether we need to keep the generator on, and when the generator is on, how much we need to generate. Okay. And so we will discuss two different types of problems. The first one is economic dispatch later. So this is the problem of we have different types of generators. So I is the generator index. And so what we want to do is when we have n number of generators, summation from I equals 1 to n. This is the total cost of generating power. Of course, we need to have some subject. So the total amount of generation should meet some demand, which is denoted by P. And then we want to minimize this cost. Minimize. Very easy convex optimization problem. Quadratic function with a single equality constraint. Okay. And you know how to solve it using Lagrange multiplier, right? So this problem is called economic dispatch problem. But here I assume that there are n generators and all of these generators are on. But now we have this term, and we may not need to turn on all the generators to minimize the cost. And that requires the decision of which generators to turn on and off. Okay? So that problem is called unit commitment. Here, this unit means generators. So in the unit commitment problems, we also need to determine the amount of power to generate, but also the generators to turn on. Okay, so in these problems, this is a mixed integer programming, mixed integer nonlinear programming, because this is a quadratic function, this is not a linear function, but it has a binary decision variable. So the mixed integer and nonlinear programming, MILP. MILP is mixed integer linear programming. This is not linear programming, mixed integer nonlinear programming. So MINP, but I'm not sure this kind of abbreviation is used or not. But anyway, you know what I'm saying. We will discuss these things later. And typically, of course, this is more difficult to solve this one. This is very easy problem. But it's not easy to obtain the optimal solution, because when we have binary decision variable, then typically to find the optimal solution, when there are n binary decision variable, actually we need to do exhaustive search for all the combination. So the total number of combination is 2 to the n, and we have n binary decision variables. So there are some heuristics to solve this kind of problem, like a genetic algorithm, blah blah blah. Maybe we can talk about that later. So generators become more efficient. So the meaning of generators becomes more efficient means that these coefficients is about the efficiency of the generator. So when they manage their generators well, then they can generate the same power with less cost. And so the production cost decreases, and they go to a competitive market, and the price can decrease, and the price to consumers decrease, and we can expect economic benefits, and also generator needs to become more efficient, and this is a positive feedback. Why is it rotated? Why is it like this? How can I rotate? Oh, So this is North American electricity market, and actually you see different colors, and you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different colors here, and the abbreviation CAISO, ERCOT, PJM, MISO, New York ISO, blah blah blah. So they are about independent system operator. I didn't explain the concept of independent system operator, ISO, yet, but yeah, they manage the market, the wholesale market. So please remember the name CAISO, which is responsible for California, ERCOT, which is responsible for Texas, and PJM, and New York ISO, and MISO, and some other, I guess. Actually, this ERCOT is interesting in the sense that, do you know that Texas was a republic country before? Texas was an independent country before. In 1890, I'm not sure, check it. So there was a Republic of Texas. So that means Texas didn't belong to the United States. Okay? And later it was merged to the United States, and there was a war between Mexico and the United States. Check it. So in Houston, there is a place called Alamo. There was a place where the battle was very severe. Anyway, yeah, so what I want to say is Texas was an independent country, and they have their own power system. So they are ready to be independent again from the United States at any time, because they have their own independent power system. Okay? This is kind of joke, but yeah. And PJM is often cited about new types of market, like a real-time market. CAISO, I think you heard this name before when we talk about the time of use, the time varying electricity price, right, which is called TOU, time of use. TOU means the electricity price that changes over time. We will have a chance to discuss this later. Time of use. This is the electricity price. That changes over time. So currently in Korea, for the residential customers, we know that our electricity bill is charged based on the total amount of energy we spend in 1 month. Okay, that means for the residential customers, we do not have the concept of electricity price per kilowatt hour. So electricity price, the price, we do not have the concept of the electricity price, can I say, depending on the time. We do not have that concept. We just charge the customers based on the total amount of electricity they consume in 1 month. But in the United States, they have a TOU, so the price changes over time, and they can increase the price when they want to reduce the total amount of load in some area. Okay? So then the customers need to respond to the price. Okay? So this demand can respond to the price. That is called demand response. Okay, let's talk about market structures. Yeah, we will see a vertically integrated utility, the monopoly case. And there are several purchasing agencies. and wholesale competition and retail competition. So let's go one by one. Yeah, this is the figure you will see in your textbook, maybe at page 3. What it says is, so far a lot of explanations, a lot of slides are not in your textbook. This is the page 3 in your textbook. So in the case of vertically integrated utility, we have generation part, transmission part, and distribution part. And yeah, they serve customers. This is the traditional model of electricity supply. The solid line is for electricity sale, this one. And this dotted line is electricity flow within a company. Then we can think of several DISCO. DISCO means distribution companies. Okay. So this is one kind of a variant on the traditional model of electricity supply. So here, generation and transmission are still vertically integrated, but we have several DISCOs. Or another model is incumbent vertically integrated utility, with IPP. Here, this IPP means independent power producer. In Korean, that is called 독립발전사. Okay. So, as I told you, before 2000, KEPCO owned the generators, the transmission line and distribution line. But after that, because of the privatization, the generation part was split. Okay, so KEPCO does not have this generation. But in this figure, still we have a vertically integrated utility and independent power producers, IPP. So this is an early stage of introducing competition in the generation market or wholesale market. So wholesale electricity market structure is like this. We have several generation companies denoted by GENCO. And we have several distribution companies, DISCO, and this is a wholesale market. So yeah, each DISCO serves the customers in its territory, okay? And they need to purchase power in this wholesale market from the generators, GENCOs. So these GENCOs are the sellers in the wholesale market, and DISCOs are the consumers or buyers. Consumers or buyers. So sellers and buyers, they meet in this wholesale market. Here we have the terminology ISO, TSO, and MO. We will get to each of these in next slides. ISO, we already discussed that, independent system operator. TSO, transmission system operator. MO, market operator. Logically, you can divide the concept into 3 pieces, but in reality, sometimes ISO and TSO are same, or ISO also functions as a MO, etc. It depends on the situation, country. And this is another structure, market with retail competition. So here we have competition in wholesale market only. And in the retail market, there is no competition because this DISCO has the customers to serve. Okay? That means you cannot choose the distribution company. Okay? But in the next slide, the market with retail competition, we have another types of market that is called retail market. So wholesale market, 도매시장, and retail market, 소매시장. And in this scenario, the customers can choose the retailer, which can provide better service with cheaper price. Okay, so we can expect competition. between retailers. So here, this retailer is the buyer in the wholesale market, but these retailers are sellers in retail market. So they are like in Korean. They are like what? 상인, 거간꾼, something like that. So they want to buy the energy at a cheaper price and want to sell at a higher price over that. So that's the margin of the profit they can expect. And interesting things is that ISO, TSO, and MO. So this figure is about market structure, but no, when we talk about power system economics, of course we have a market, but this should be a physical power system, right? So there are some entities who manage the networks. In the case of transmission network, ISO or TSO or MO, they can manage that. In the case of distribution network, that should be managed by distribution companies. And yeah, in Korea, I think I already told you this. We have, Korea Power Exchange, 한국전력거래소, which is located at Jeju. Actually, Minsu visited. And we have TEPCO. Yeah, we have only these two things. So KPX manages this wholesale market. And KPX is also ISO. KPX is independent system operator. And yeah, we do not have this retail market currently. So and we have a single discount. Dramatis persona. This is Latin. And the meaning is, who are the characters in the play? So in play or novel, you can think of the players. They are the drama. This is drama. Persona is person. You know what persona means? Oh, you don't know persona? No. So, what is the meaning of persona? Well, actually, we are using persona in Korean as well, right? Or 본캐, something like that. Anyway, so dramatis persona. Let's see the players in the play. The old model. Yeah, the utility company is the only one who plays. And the customers, you are the customers, and you you remain silent. Okay? And the regulator, of course, there are regulators, but they are behind the curtain. Okay? And this is the old model. Interesting figure. So, let's see the customer, the load case. So this is from the data from National Grid. National Grid is a utility company in the UK and the US. And actually, the y-axis, the unit is 1,000 of megawatt or gigawatt. Okay. So the peak load is just 50 gigawatt. So you may think this is odd. If you think this is the total load of the UK, this is odd. So this is not about the total load of UK. This is the load served by National Grid only. In the UK, there are several utilities. Okay? So please don't be confused. This is not the total load of UK. maybe you are not confused at all because you don't know total load of UK, total load of Korea. What did I say before? What is the total peak load of Korea? Hot summer day. Last summer day, 80 to 90 kilowatt. Then what is the total load of the United States, roughly? You have no idea. I emphasize, you need to get some rough numbers in economy and in power systems. So, roughly speaking, GDP, gross domestic production. What is the GDP of Korea last year? Roughly, the order. Oh, very close. 1,500조. So let's just assume that $1 is just 1,000 won for simplicity. Okay. So that this means, yeah, $1 billion. Or this is $1.5 trillion. This is your guess. Check it. And I think this is, this approximation is closer than this one. This is more accurate. So roughly speaking, the GDP of Korea is $2 trillion. $2 trillion. And what's the GDP of the United States then? Guess. Do you have any idea? You have no idea? Well, around $20 trillion. Okay. Then what about the total GDP of all nations on Earth? You have no idea? Earth. Roughly $100 trillion. What is the number 2 in GDP? Yeah, China. Then can you guess their GDP? Actually, I don't know exactly, but check it. Maybe $15 trillion or something like that. And so US, China, who is number 3? Japan. Who is number 4? Germany. Who is number 5? UK. Who is number 6? France. Who is number 7? Italy? I don't know, I'm not sure. Anyway, so what I want to say is that this GDP is proportional to the total power consumption of the country. That means the total load of the United States is 10 times higher of Korea. Okay? So Korea, yeah, 80 gigawatt, 100 gigawatt. Then the United States, 1 terawatt peak load. And Canada, maybe I think the GDP of Canada is slightly higher than Korea. Check it on your own. And their total load is also slightly higher than Korea, or which is similar. So the GDP and the total load or total generation are very closely related. Anyway, so this data is from National Grid. A minimum summer day, typical summer day, and typical winter day. They use electricity for heating a lot. Anyway, this is given, and in the case of this old model, the operators, here the operator means ISO, they assume that the load is given and the generators, the sum of the total generation must meet the total load all the time. The load is given. The load does not respond to the price. It is fixed. Okay? And all the responsibilities are imposed on the generator and independent system operators. So in that sense, in the old model, the load was called the load. The load is called this kind of phrase. This is an old phrase, okay, that reflects the old model. And in the vertically integrated monopoly utility case, they owns and operates all the assets, generating plants, transmission network, distribution network, and the control center. And this monopoly is over a given area. And let's see several actors after full unbundling. This full unbundling is kind of ideal case. Okay, so this is a conceptual case. So we have a generating companies, GenCo, and we have distribution companies, DISCO, and electricity retailers, market operators, MO, independent system operators, ISO, remember this one, okay. Transmission company, Transco, consumer, and regulator. Okay. So we logically divide actors into 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is a conceptual case, and depending on the countries, some functions are merged into one. Okay. Let's talk about generating companies. We have 12 minutes. I want to finish chapter 1 today, so let's speed up. The generating companies owns and operate power generating plants, and they compete against each other to sell energy in the wholesale market. And the advantage of this competition is more efficient plants, and cheaper fuel, and higher plant availability, because they need to manage their power plants well to get into the market. Okay. What about distribution companies? They own and operate the distribution networks, but this can be a regulated business, and the revenue is determined by the regulator based on the value of the asset. And so monopoly for the sale of the electricity in their territory when there is no retail market. And about the retailers, retailers you see in the wholesale market and retail market, and in between we have retailers. They buy electricity energy from generators and sell the energy to consumers. They do not own large physical assets, and they are often owned by generator or distribution companies. And the advantage of competition is negotiate good price with generators, identification of good customers. It means that I think the meaning of good customer is that they respond to the price signal. Okay. And efficient billing system. And market operators facilitate trading of electricity and matches bids and offers. So here the keyword bid and offers. These two keywords we'll use in chapter 2. Anyway, you know the meaning. They matches bids and offers submitted by the buyers and sellers of electrical energy. So here the bid is for buyers and offer is for sellers. And they runs the market settlement system. Market settlement. This means the seller and buyers reaches to an equilibrium and the price is determined. And monitors delivery of energy and forward payments from buyers to sellers. And the requirement of market operator is fairness and independence. Independence and fairness means that these market operators should not be biased either to sellers or buyers. Okay? It should be neutral. And efficient technologies to support trading. Efficient settlement of trades. Okay, ISO. By the way, these concepts are logical. And as I told you, in some case, NO and ISO are merged as a one, depending on the countries. In Korea is that case. So ISO operates the power system and maintain load generation balance. This is the most important role of ISO. At any time, ISO or KPX need to make sure that the total amount of generation is equal to the total amount of load. Okay. Otherwise, blackout can happen. Okay. So they are responsible for operational reliability. And they operate the market of last resort. What's the meaning of last resort? English question. In Korean, that is called 최후의 수단, or in law, 1심, 2심, 3심, it means 3심. So they operate a market of last resort. That means ISO is responsible for the market and the whole system. So their role is very, 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 very important and critical. And so must be independent from other participants to ensure fairness of market. And they, ISO, do not own transmission network. Don't be confused. ISO does not own a transmission network. They own only computing and communication assets. They just compute. They compute the optimal power flow. Compute. They are saying they compute. Okay. And sometimes ISO is known as Regional Transmission Organization, RTO. And the transmission companies owns and maintains transmission assets, the transmission lines, transmission network, substation, what is it? 변전소. I think you may not have a chance to see substation in Korea, but as substations, the high voltage is transformed to a lower voltage in these lines. So Transco operates these assets as instructed by the ISO. This is what Inji, your colleague, complained. She is working at Capcom. And then she gets some instruction from the ISO KPX. Cut off some line or turn on the line, blah, blah, blah. So all the kind of computation is done by KPX. Okay? And based on that order, Capco needs to manage the transmission network. This is also regulated business. The revenues are determined by the regulator based on the value of the assets. TSO. Yeah, TSO combines the function of ISO and transmission companies. And Europe has TSO, and North America has ISO or RTO. So maybe you are confused. So just you can think ISO, TSO, RTO, they are similar, the same. Okay? Depending on whether it's United States or Europe, the terminologies are different. But similar concepts. Large customers, industrial or large commercial consumers, and in Korea, POSCO or Samsung Semiconductors, they are large commercial consumers. And these large consumers buy electricity directly from the electricity market or some IPP, independent power producers, directly. And yeah, in Korea, the price for these commercial consumers, the price changes over time, this part, and they can sell demand response. Okay. So what it means is these large consumers can reduce or shift load in response to price or an incentive. So when price is very high, they can reduce their load, or they can be offered to get some money if you reduce the load by some amount. They can get some incentive from KPIs. Small consumers like us, residential or commercial consumers, building or department stores, something like that, buy electricity from a retailer or a distribution companies. Buy electricity at a fixed price, or in Korea, we are using 유진제, you know what that means. But they are too small to sell services like demand response services directly in electricity market. So we can think of these small consumers sell demand response through an aggregator. The aggregator means 중개 사업자 in Korea. Okay? And the concept of this aggregator can be applied for demand response, the consumer case, but also can apply to prosumers with some small amount of renewable generation. Okay? So that is the concept of a virtual power plant, VPP. So some of you are involved in the project, was involved in the project of VPP. So in Korean, this was called 가상 발전소, but these days 통합 발전소 is also used. Regulator. There are two types of regulator: commercial regulation and technical regulation. The commercial regulation means it's not about the the system. It's about money. So they oversees the operation of the electricity market and determines the allowed revenues of the monopoly rate of return. And please remember this name, FERC, Federal Energy Regulatory Commission. This is a regulatory body responsible for commercial regulation. Okay? And WUTC, use this terminology. Today, so this FERC is about wholesale and transmission, and this WTC is about retail and distribution, about commercial regulation. By contrast, we have technical regulation. That means they set the standards for power system reliability and power quality. Power quality means the frequency and the voltage fluctuation or harmonics, blah, blah, blah. And so they enforces technical standards. Okay? And please remember this name, NERC. NERC is about technical regulation. In the United States and in Europe, ENTSO. And typical rebundling. Rebundling means we split this vertically integrated structure into many pieces, and then we can recombine some parts, like distribution plus retail, generation plus transmission network, generation plus retail, system operator plus market operator, the case of Korea, transmission owner plus distribution owner, KEPCO, But this thing is not allowed in Korea. Generation plus retail. This is prohibited by law, and that is called 발판금. Generators cannot own the retail business. So that's why Capco cannot have generator parks. But these days, the thing is that we have small renewable generation. And because of this one, Capco cannot have solar power plants, even if they are very small. And I will talk about these things later. That's it. So our perspective of model, point of view of the vertically integrated utility is the only one that matters. New model, we have many actors, and each actor has a different perspective because his motivation is different. And because we are considering the fully competitive market, we have different stakeholders, and they want to maximize their own profits. Right? So how does it make money? And they have different views and ways of looking at the same problem. That's why we need to have the concept of game theory. Something like that. Okay, so let me stop here. And I will see you on Wednesday, and we will have a quick